All right, looking at it 3.5, find and use slopes of the line. So again, you guys have seen this before. Slope should not be new. You covered this in Algebra 1. Please remember the slope formula. It's not going to be given to you. So the slope formula is y2 minus y1 over x2 minus x1. If you are given the graph with a line, yes, 100%, you can just count, okay? Another name for slope that we have most likely seen is rise over run, okay? Again, if you were given a graph, yes, that's fine. You can count your rise over run. In equations, when you're given equations, for example, slope-intercept form, which we will cover, in equations, your slope is labeled as m. So if you're looking at this, they are giving you slope, which is m equals the slope formula. So please remember this. You will be using slope and you will be solving. You're normally given 2 coordinates, and that's what you're using to find your slope. All right, there are 4 types of slopes. Most of us should already know positive and negative, okay? Think of stocks. We have all maybe hopefully seen the graphs in a stock market. When it's going up to the right, that means you're making money, it's positive, okay? When it's going down, it's normally red, and that means you're losing something, so that's negative. Okay, keep in mind you're always looking at it from left to right. Never look at it from right to left. Don't think as this is going down because it's not. It's going up. Okay, moves to the right, falls to the right. 2 that most students get confused on is 0 and undefined. You have to know these for your test. You have to understand the difference, okay? 0 is when you have a horizontal line. When you have y equals a number, that's your 0 slope. And then when you have x equals a number, that's called undefined. Okay, that's your vertical slope. So when you are looking at it, a good way to remember it is there's a slope face that I like to show everybody. It looks like a little face. Okay, this is my positive slope, going in the positive direction. This is my negative slope, so I'm going to write negative. You have that horizontal, that vertical line, which is undefined, so it kind of looks like a nose. And then you have your 0 slope, which is your horizontal line. So this is what, like the slope face, it helps you determine what's 0 and what's undefined. So we should already know positive, we should already know negative. It's just the undefined is vertical, and the 0 is horizontal always.
Oh, I see the face.
Do we have any questions on this? All right, theorem slope of parallel lines. When you have parallel lines, the most important thing you have to remember is parallel lines have the same slope. Okay, they will always have the same slope. So, giving you an example, let's say the equation of this blue line was y equals negative 1/2 x plus 5. Okay, that means the slope of this blue line is negative 1/2. So if I'm looking at the red one, what should my slope be for the red one if they're parallel lines? Good. It should also be a negative 1/2. So I could have an equation written as y equals negative 1/2 x plus 10. Okay. So yes, same slope means they're parallel lines. If they're telling you they're parallel, they have to have the same slope. So here is my slope. Here is my slope. All right, perpendicular lines. Perpendicular lines, main thing about perpendicular lines is the slopes are both opposite and reciprocal. You have to know both. So if you're given perpendicular lines, okay, so this is the symbol for perpendicular if we forgot. Your slopes are both opposite. It cannot be just one. It has to be both. And reciprocal. So giving you an example of this. If my blue slope was negative 3 over 2. What's the opposite of negative 3 over 2, Katya? No, go ahead. You could give me the whole thing. What would it be? Good. So just showing you what opposite and reciprocal means, just so we don't get mixed up. If I have 3 over 2, negative 3 over 2, the opposite, I'll write it on top, is 3 over 2, meaning it's positive. Then the reciprocal would be 2 over 3. So the answer for the red one would be positive 2 over 3. Okay, so you have to think opposite, reciprocal, and then get to what the answer would be. So it has to be both. It cannot just be one. It must be both in order to be perpendicular. So if they're giving you options, let's say on your homework, and it says, what is the slope perpendicular to negative 3 over 2? And you decide to put positive 3 over 2, that's incorrect. It has to be both opposite and reciprocal, not just one or the other. All right, sometimes, always, never. So if you need help with this one, draw the little slope face, okay? Don't forget to remember that. So it says, the slope of a vertical line is blank 0. So which direction is a vertical line going? Good, up and down. If you forget, horizontal has the word horizon. When you're looking out in the ocean, you have the horizon. Okay, the sun sets and rises on the horizon. That's going from left and right. So if it's asking the slope of a vertical line, so remember your little slope face. If I decide to draw a vertical line, is that a 0 or undefined? Good, that's my little nose part. I have positive, I have negative, I have my undefined, and I have my 0. So the slope of a vertical line is blank 0. What would that answer be? Good, that is never 0. The slope of a vertical line is what? Is undefined. Okay, the slope of a vertical line is undefined. It is never 0, it is always undefined. Looking at the next one, the slope of a horizontal line is blank 0. Horizontal goes which way? Left and right. So looking at my slope face, what would it be? Always. Okay? Horizontal line is always 0 because there's no slope. Okay? There's no slope for a horizontal line. So this is always. The slope of a line that rises to the right, so I'm going to draw that. It rises to the right, is blank positive.
Always.
Good, this is always. And then the slope of a line that falls to the right is blank negative. Good. Always negative. All right, this one says find the slope of a line through the 2 points named. So, slope. Who could tell me what's the formula for slope, Sebastian?
y2 minus y1 divided by x2 minus x1.
Good. Over x2 minus x1. So they're giving me my coordinates. Can I just count these? If they were graphed, yes. If you would like to graph them, sure. However, easiest way to do it is just plug it into the formula. They're small numbers. We can just plug these in. So I'm going to go ahead and plug them in. I'm going to go ahead and label first. I have x1. I have y1. I'm going to make this one a different color. Here's my y1. Then I have x2. And I have y2. So plugging in what I have 5 minus 4 over -4 minus -3. When I have two negatives, or a negative and a subtraction next to it, what can I do?
Put it in parentheses and multiply it.
I'm going to add them. When you have a negative and a subtraction sign.
Multiply it. Then make it turn positive. Boy.
You're going to change it to plus.
Yes, I did. But I gotta multiply it because negative times a negative is a positive.
Okay, I get what you're saying. -1 times -3, you're going to have +3. Good, that's fine. All right, so looking at it now, solving it. 5 plus 4, what am I going to get?
Minus 1.
Okay, 1. Okay, if I get a 1 over, what's negative 4 plus 3? Negative 1. So if I were to, let's say, use rise over run, how would I do this? What would I do?
Down 1 over 1.
Good. So anytime looking at your slope, if it's a negative slope, doesn't matter which number is negative, you're going to go down 1, then I'm going to go in which direction?
Left.
Left or right?
Right.
You're always going to the right. Okay, you're always going to the right when you're using slope. Then you're going to go to the right 1. Okay, your negative and positive signs, you're determining if it's down or up. So looking at the next one, doing the same thing, plugging in what I have. I'm going to have y2, which is negative 2, minus negative 3 over negative 1 minus 6. So again, looking here, I have minus a negative. I'm going to change it to a plus. And solving it, what's negative 2 plus 3? Positive 1 over negative 7. So if I were to put this one on a graph, if I were to graph it, which direction would I be going in?
Right.
Good, I'm going to go down 1, and then am I going left or right?
Right.
To the right 7. Remember, yes, even though the negative is with the 7, the entire fraction is negative, so that's telling you to go down. So let's say we solved it and we got negative 1 over 7. That's still the same thing. You're going to go down 1 to the right 7. Okay, the entire thing is negative. So looking at the next one, let's look at C. Same thing, solving it, I have negative 2. Let me make this a little smaller. I'm sorry, not negative 2. Negative 4 minus negative 4 over negative 3 minus 8. Okay, these I'm gonna add. Okay, what's negative 4 plus 4? Good, I'm gonna get 0 over negative 11. Okay, would this answer be 0 or undefined?
0.
This would be 0.
Come on then.
Okay, so looking at it, this answer right here would be 0. This is a 0 slope. This is a 0 slope. So let's go ahead and look at D. That's a good question. When would it be undefined? I have 9 minus negative 2 over negative 6 minus negative 6. So changing what I could change. I'm then going to get 11 over 0. This answer would be undefined. Okay, this one would be undefined. Yes.
For like the formulas kind of slope, does like the order matter? Like
Okay.
with the y's?
When you say does the order matter? So if you were to do y1 minus y2 over x1 minus x2, that's fine. Okay. As long as your y's are on top and your x is on bottom, we should get the same answer. Okay. So for example, if you were to switch this order for this one, and you were to put negative 3 minus negative 2 and 6 minus negative 1, this would be your answer right here, which is the same thing after you were to graph it. Okay, so Yes, if you were to switch these and say y1 minus y2 over x1 minus x2, that's fine. We should still get the same answer. Okay, so complete the table. For r is parallel to s. Let's write some notes on here. If it's parallel slope, what does it have? Good. If it's a parallel slope, it has the same. If it's perpendicular, what does it have to? Good. It has to be the opposite. And it has to be the reciprocal. Has to be both. So, looking at this one, looking at r, if they're giving you r is negative 1 over 2, Bryce? No, because if it's already negative, you have to change it to positive. So like for example, for this one, for A, perpendicular, R is perpendicular to T, so what would T be? It would be positive. So if you're putting negative reciprocal, I would say no because they're not always negative. It's the opposite. It has to be the opposite sign. So yes, for this one, for T, the answer is 2. It would be considered 2 over 1, but that's the same thing as saying 2. What would S be? Good, negative 1/2. These are pretty easy. Hopefully we'll fly kind of through these. Looking at the next one, R for B. R for B would be, what was that? Negative 6 over 1, but that's the same thing as saying just negative 6. So what would S be?
Negative 6.
Good.
Would I get credit for writing like either? Like there's a fraction?
Either one is fine. Yeah. If you wrote negative 6 over 1, that's fine, but simplest form would be negative 6. All right, C, what would the answer be for R? Yes. What was it?
1 over
Yeah.
5.
Good, 1 over 5. What about for T? Hernan?
Negative 5.
Good, negative 5. All right, D for R. Go ahead.
Minus 4.
Negative 4. And then what about T? Go ahead, Katya. 1/4. Good. All right, let's look at R for E. Go ahead. Good. Negative 1 over A. So, oops, that's not an A. So think of your A as a whole number. Putting it as a fraction would be over 1. Okay, so it's just a regular variable. Changing it to a fraction, you put it over 1. So the reciprocal is 1 over A, and then the opposite is negative. So what would S be?
Negative 1 over.
Good. Negative 1 over A. And then looking at the last one, what would my answer be for R? For F? Good. Negative 4 over 3B. And then for S?
Negative 4 over 3B.
Good. The same. Because they're parallel. Good. Any questions on these? These are pretty easy. Definitely just practicing opposite reciprocal and the same slope. Think about this question. It says, if R is parallel to S and R is a horizontal line, what is the slope of S?
0.
Good. So just visually drawing it out so you can see what it's talking about. Horizontal goes this way. The slope of a horizontal line, this is R. My slope is 0. If it's parallel, here's my S. My slope for S is also going to be 0. Looking at example 5, if K is perpendicular to N and N has a slope of 0, what is the slope of K? Hernan? Good, undefined. So visually drawing it out, if it has a slope of 0, that means it is a horizontal line. K is perpendicular, so K is going to be undefined. So my slope for K, undefined. All right, this one says slope-intercept form of a line. So slope-intercept form is written here. Again, this is something that we should have covered in Algebra 1, slope-intercept form. Key things about slope-intercept form is 1, your M, which is your slope, your B, which is your y-intercept. Can someone tell me what the y-intercept is?
Something that crosses the y-axis?
Yes. Say it one more time.
Oh, something that crosses the y-axis?
It's the point that crosses the y-axis. So please make a note of that just in case. Okay. Point on your y-axis. Okay, it's the point that crosses through the y-axis. So for these questions, it says, find slope and y-intercept, then graph it. And we'll graph it at the end. So, looking at this, A, is this one written in slope-intercept form?
No.
No, so I need to go ahead and rewrite it. So I'm solving for y. So I have 2x minus 3y equals 6. Solving for y, getting rid of my y, putting it to one side. I'm going to go ahead and subtract 2x from both sides. Be aware of how I'm writing this equation, because I'm going to go ahead and put my negative 2x to the left, because remember, slope-intercept, you have your x first, then you have your y last. So next I'm going to go ahead and divide both sides by negative 3, dividing everything by negative 3. Then I'm going to get y equals 2 over 3x minus 2. All right, let's go ahead and just find the slope and the y-intercept. So because I plugged it in and I put it in slope-intercept form, looking at A, can somebody tell me what is my slope for A? Good, I have 2 over 3. What's my y-intercept? Good, it's negative 2. All right, let's go ahead and look at B. What is my slope for B? Good, negative 1 over 4. And what's my y-intercept? 2. And then C, what is my slope for C? 0. And my y-intercept is negative 3. Okay, so we're going to go ahead and graph this. I'm just going to kind of highlight. I'm going to do it in this one in blue. Okay, graphing should be the easiest part. This one I'm going to do in my purple. And then this one I'm going to go ahead and do in orange. If I could get the orange. Okay, graphing. Let me go ahead and paste a graph on here. All right, here is my graph. We're going to go ahead and graph it. First thing I'm going to do is graph my A, which is my blue one. First thing you're going to do is put your dot on your y-intercept. So for my blue, my y-intercept is going to go on my negative 2. And then is my slope positive or negative? Positive. How many times am I going up?
2.
Twice. And how many times am I going to the right? 3. So graphing it going up twice over 1, 2, 3 should be right here. Okay, and I'm just going to graph one more just to be more accurate. I recommend 3 so it's as accurate as possible. So going up 2 over 3, 1, 2, 3, right here. Going ahead and graphing it, please make sure it's as straight as possible. And most important thing, do not forget your arrows. If you forget your arrows, you will get points off because it is a continuation of a line. Okay, next, that was my blue. Let me go ahead and do my purple. What is my y-intercept for B?
2.
2, good. So put that dot on 2, and then what's my slope? Is it positive or negative? It's negative. Negative 1 over 4. So that means I'm going in which direction? Up or down?
Down.
I'm going to go down 1 over 4. 1, 2, 3, 4. And then I'm just going to do one more to be as accurate as possible. Right here. Okay, graphing it. Make sure it goes through my line. And again, don't forget your arrows. And then the last one, what is my slope for C? 0. What's my y-intercept?
3.
So which direction, negative 3, good. Which direction is my line going to go? What direction is that? Horizontal. And again, don't forget your arrows. Questions on this and how to graph it?
Not so.
Okay. All right, for this is write an equation of a line that passes through the points. That is parallel, so please follow along with this. Okay, you are writing a new equation, so it has to be in slope-intercept form. Parallel, what do I know about parallel slopes?
This is the same.
Good, they have to be the same. So that means for my new equation, what's going to be the slope of my new equation? Good, it's going to be 2. So I'm going to go ahead, I'm going to write it in blue. My new slope is going to be 2.
Oh my god.
All right, now I am going to be using the information they gave me. So I'm going to look at it. They gave me these points. I'm going to go ahead and I'm going to plug it in to what was given. So next step, I already know my slope from my new equation, but now I need to write my new equation. So I'm going to go ahead and solve for B. How am I doing that? Like I said, I'm going to take what was given. My y is 1 equals taking that new slope times your x, which is -1, plus b, and I'm solving for b. So solving it, what's 2 minus 1?
1.
2 times -1.
Negative 2.
-2 plus b, and if I'm adding 2 to both sides, what's 1 plus 2? Good, so b equals 3. Now I have information for my new slope. So what would my new equation look like? I'm going to use the information that I solved for. Y equals, okay, you're always going to have y equals. My new slope was 2x, and then my new b was 3. So this would be my new equation. Okay, where am I getting this information? Just so you see where it's coming from. This is my new slope, and this is my new y-intercept. Yes. Okay, so how did I solve for b again? I used what they gave me, the coordinates that they gave me, because remember it has to pass through this line. So I'm going to take that information and plug it in for x and y, and I'm using the new slope. So even though it looks like I'm taking the same thing, I'm not. I'm using the new slope for my new equation because it's parallel. So looking at the next one, now it's telling me they're perpendicular lines. So again, what do we know about perpendicular lines?
Opposite.
They're good. They're opposite reciprocal. So looking at it, I'm going to go ahead and write that down. It has to be opposite and reciprocal. So is this written in slope-intercept form? No. So now I need to go ahead and rewrite it in slope-intercept form. So writing it in slope-intercept form, I'm going to have going ahead and subtracting 2x from both sides. Oh, you can't see that. Okay, minus 2x on both sides. These are going to cancel out. I'm going to get y equals negative 2x plus 2. Now is it written in slope-intercept form?
Yes.
Yes. So now what I have to do is I'm going to go ahead and look at it. What would my new slope be?
2.
Good. My new slope would be 1/2. Okay? So same thing I did before. I'm going to take what they gave me. I'm going to take what they gave me. I'm going to go ahead and plug it in. So I have my y, which is 3, equals my new slope, which is 1/2, times 2, and then remember, I am solving for b. So solving it, what is 1/2 times 2?
1.
Good, so I'm going to have 3 equals 1 plus b. Subtract 1 from both sides. I'm going to get 2 equals b. So now writing my new equation. My new equation is going to be y equals 1/2 x plus b. So again, where am I getting these from? This is my new slope, this is my new b, and this is my new equation. All right, questions on this?
B or 2?
I'm sorry, you're right, it is 2. My mistake. This is a 2. Good. Plus 2. All right, questions, comments, concerns on this one? If you can graph it, yes, you could graph this line. You would put your 2 on your intercept, and then you would show me your slope. You go rise 1 over 2, rise 1 over 2. All right, this one is a little lengthy. I need you guys to pay attention for this. It says find the distance from the points 1, 0 to the line. We are going to use a formula in this that we covered in chapter 1. Which formula do you think we're going to use?
Distance formula.
Distance formula. So please make sure you remember the distance formula. I will write it in here again. I need you to understand what this question is asking. Find the distance from the point 1, 0 to the line. So I'm just going to draw that, just a rough sketch. Here is my point. Let's say it's a negative line, a negative slope. Here is my line, okay? When you are finding the distance from a point to a line, what do you have to take? Which line? The shortest line, which means your line has to be what? Perpendicular, okay? So now, like we did before for example 7, we have to find that perpendicular equation. So how am I doing that? I'm doing it in steps. So my first step is find the equation of the perpendicular line. Step 1, find the equation of the perpendicular line. So we should know how to do that. I'm going to go ahead and look at what they gave me. What would my new slope be for my perpendicular line? What would my new slope be?
1.
Good, it would be 1. And then I'm going to take that information that we had, those coordinates that they gave us from before, and we're going to go ahead and plug them in. So I'm going to take this and I'm plugging it in. So right now I'm going to have 0 equals my new slope times 1 plus b. I need to solve for my b. Remember, I'm trying to find that equation. So what's 1 times 1?
1.
So I have 0 equals 1 plus b, and how do I get rid of that 1?
Subtract it from both sides.
Good, subtract it from both sides. So b equals?
Minus 1.
Good, negative 1. So my new equation is going to be y equals 1x. I don't necessarily need to put the x there. Minus 1. Okay, so I found the slope of my perpendicular, the equation for my perpendicular line. Now I have to go ahead and find that intersection. Meaning, where did these points intersect right here? So that's what I'm going to do for step 2. Step 2, find the intersection. Okay, how am I going to do that? I'm solving for systems of equations. So I'm going to take what they gave me. I'm going to now take the 2 equations, systems of equations. What are my 2 equations? Pay attention to how I'm going to set this up. I have y equals negative x plus 3 and y equals x minus 1. I need to find my coordinates. So my coordinates for this, I'm going to set it up as x minus 1 or negative x plus 3 equals x minus 1. And I'm going to go ahead and solve for x. Subtract x from both sides. Then going to get negative 2x plus 3 equals negative 1. Subtract 3. And then last, divide both sides by negative 2. And then I have x equals 2. So I found my x. How do you think I would find my y?
Plug in.
Good, all you have to do is plug it in. So I'm going to take this, and I'm just going to plug it into this one. I'm going to get y equals 2 minus 1. And what's 2 minus 1? Y equals 1. And then step 3 is to now plug it into the distance formula. Okay, if we forgot distance formula, please remember distance formula. So I'm going to use my coordinates. I'm going to use the ones they gave me. So going back to the top, it was 1, 0. And then what I solved for, which was 2, 1. So distance formula, x1 minus x2 squared plus y1 minus y2 squared. Plugging in, I'm going to have 1 minus 2 squared plus 0 minus 1 squared. What's 1 minus 2? Good. And this is also negative 1. What's negative 1 squared? 1 plus 1. And what's 1 plus 1? 2. Can I simplify this? No, this would be my answer. Okay, this would then be my answer. All right, your test is Thursday, October 3rd. We will have review tomorrow and the day after. Homework is on big ideas. Please show the work where you have to show work.